Hi, my name is Kazem, as I said, and I'm working right now for this company called Trulio. And at Trulio, what we do, we are using machine learning and data mining to do online verification. And currently, we are hiring data scientists and people who have experience in machine learning or data mining. Therefore, if you are interested, you can check out our website. Yeah, I did my PhD. I finished my PhD last year in University of Victoria. I did my PhD in prediction, machine learning, and social network analysis. And last year I was in Amazon Hackathon. I went to Amazon Hackathon last year, September. And I was working with my, several teammates, and then I was thinking that, okay, what kind of app? That was before election. And then I was thinking that, what if, because of my background, I'm very interested in election in general, and I said, okay, US presidential election is coming, what if we try to see if we can predict US election? And therefore the question was that, okay, can we do this? Is this problem is possible? Or can we get close to answering such a question? But the main challenge, of course, in the first place is that you need data in order to do prediction. Okay? That's the main challenge. Therefore, the question was that what kind of data we can use in hackathon in order to, for example, see the trend of what people are talking on or what people are supporting. And the first thing that came to my mind was Twitter. And the reason is obvious, because Twitter has open API that you guys can freely use their API, collect data, okay? And it's not like Facebook closed kind of company that they don't allow you to analyze their data. Therefore, I said, okay, then we can go for Twitter. But there were other motivation behind that. I don't know if you guys remember from 2008 when Obama was very successful in running his campaign using social media compared to his opponent, who was McCain, who was kind of old school guy that and he was not into, for example, social media. Therefore, Obama actually, his campaign was successful using Twitter, raising money in Twitter, and talking to his followers in Twitter. And just for example, as an example, I was in a conference 1 week ago, and this very interesting picture. This picture was posted right after the election, and it's very interesting because this picture seems that it got the highest Facebook likes, as well as the highest retweets. I mean, that's the thing that I was told. Therefore, it shows that there is a big community where that people are talking about the election. Therefore, we decided to use Twitter data. The first question that comes to your mind is that, okay, if I want to use tweets, and if I want to predict election, what kind of data I can expect from Twitter? Of course, tweets, okay? But the question is that how rich this data is, what kind of dimension we have when we collect tweets, okay? And of course, each tweet, which is a text which is limited by 140 characters, comes with the time that they tweeted, the time that the tweet was posted. And also it comes sometimes, I'm sure that a very low percentage, comes with geolocation, which is very, very interesting data, latitude and longitude. And of course with the oscillators, you know who's behind that tweet, and the device that they use or the app that they use to tweet. Therefore, it's kind of multi-dimensional data, text, time, location, and other things that can kind of help us to see the trend of how community talks about, for example, election and how they discuss about different candidates. Therefore, how did we do it? I wrote a very simple Python script using 3Py library to collect tweets. And then I started running this since September 29th last year. And the crawler was supposed to run in real time and then collect the tweets using that. And but the thing was that I was just interested in political tweets. Therefore, I was collecting this on real-time Twitter stream, but I was just looking for political words like Barack Obama, Mitt Romney, and etc. And yeah, we ran this crawler from September 29th until November 16, which was after the election. We collected 40 million tweets, political tweets. And the number of tweets that we collected before election day, which was November 6th last year, was like 32 million tweets. And it's interesting to say that among those 32 million tweets, there were 140K tweets that they came with geolocation. And this is kind of gold data, and we get there why this is important. And you see that the percentage is like 0.43%. Therefore, you should explicitly turn on the geolocation on your mobile phone in order to making sure that your tweet comes with location. After collecting the tweets, I had to store the tweets into a database for analysis. I use MySQL, okay, very basic kind of data structure. And I also use KD3. And the reason that I used KD3 data structure was because I wanted to do some special kind of location kind of queries, run some location-based queries like nearest neighbor or range search. That was the reason that I had to. Therefore, that was the reason that I also used KD3 data structure in order to be able to search queries by location range, latitude and longitude. Here I just listed several tweets. I mean, everybody knows it. Everybody, I think, is in Twitter, but I just listed several tweets of political tweets that I collected that you get some sense of what people talk about. Okay, the first one, if Romney win, I'm moving to Canada. No bullshit. Okay. Mitt Romney buys followers, which is actually true. Romney bought lots of followers. I think he bought like, 20 million. Samuel L. Jackson to voters who elected and vote over, okay? And the interesting, I mean, when you see that some of the votes, some of the tweets come with the hashtags, for example, Romney, Obama, Benghazi. If you guys remember last year, there was this Benghazi attack, and many people were mad, and it was discussed during the debate several times. Yeah, and this is a kind of tweets that we collected therefore. I hope people can see. I don't know. But for these 2 months tweets, the first analysis, the first basic analysis that I was thinking that, well, okay, let's look at the data. Before getting to, some machine learning algorithms, let's look at the data, see how the data looks like. The first thing that, of course, everyone does is that you can look at the frequency of tweets. How many tweets are posted? How many political tweets are posted every day? Okay? This is starting from September 29th, and as I said, ends on November 16th. Now, when you look at this frequency distribution over days, the first question that comes to your mind, why is local maximum happens in UK? And we have also a global maximum. But I think the answer is clear. October 3rd is the first debate. It is the first presidential debate. And October 11th was the vice presidential debate. You see that vice presidential debate was not as, popular for the community as, of course, the presidential debate. And then, interestingly, you see that, no data here, because my crappy software crashed at that time. And even if I handled all the exception, I was relying on that TweePy, and I don't know, for whatever reason, TweePy probably crashed at some point. And that, unfortunately, that was before the second presidential debate. But I noticed, because I was watching the debates, I watched all of the debates, and then while I was watching, I wanted to look at the real tweets in real time, and then I noticed that, it was crashed, and then I recovered, but unfortunately it was kind of late, because it was very late at night. that's the reason that you don't see that maximum kind of things on October 22nd. And of course, the global maximum happens on November 6th. But you see that when you are getting closer to November 6th, the trend, the campaigns are putting lots of probably energy in order to tweet positive for their own candidate or negative for their opponent, whatever. Yeah, please. But sorry, can you go back? But I mean, when you look at, for example, on November 6th, I mean, you see that there are over 3 million tweets on November. But I mean, the other maximums are reaching like 1.5 kind of millions. But the global maximum is like over 3 million. The next simple analysis or basic kind of analysis that I could do was that I wanted to see how much attention each candidates are receiving from crowd, from people in the US. And for doing that, what I did, I started testing all days from September 29th, and for each day I randomly sampled 10,000 tweets. And I just searched to see in each tweet, I just checked to see if Romney or Obama were mentioned in tweets. Therefore, you can sense it that, okay, if there are lots, if the percentage of tweets that they mention Obama is high, that means that Obama has the attention of the public, kind of things. Therefore, the blue one shows the percentage of tweets that they mention Obama, and the red one is Romney. As you see, when we are getting closer to October 3rd, before that, Obama was kind of leading, and then there is a balance around October 3rd. And if you guys remember October 3rd, I think the first debate, Obama, based on critics, didn't do very well. Therefore, you see that there is balance around that time, and after that, of course, Mike Crowder, and then, but it's interesting that you see after October 22nd, the game is changed. And again, Romney started kind of losing public attention. Therefore, the percentage of tweets for Romney is going down. And of course, on November 6th, yeah, and afterward, lots of disappointment on Romney's side. Of course, I mean, which is obvious. The next simple stats that I want to show you guys is the distribution of hashtags. When you think about the hashtag concept in Twitter, hashtag basically is the topic that people want to discuss. Therefore, if you don't misuse hashtag, then you put the hashtag in your tweet in order to help Twitter in order to organize the tweets. Okay? Therefore, it's kind of topic. It shows the focus of the tweet. Therefore, what I did, I sampled 10,000, I randomly sampled 10,000 tweets for different days, and I picked these dates selectively. October 3rd, first presidential debate, 16th the 2nd, 22nd the 3rd, and November 4th, 5th, 6th, the days leading to the election. As you see, on October 3rd, Obama's percentage for hashtag is higher than Romney. Romney is the second one. And of course, you see lots of hashtags for debate because it was the debate day. And the same thing, you see that debates are mentioned on October 16th and 22nd. But still, Obama is leading, but the difference is not that much huge. But when we reach November 4th, 5th, and finally 6th, you see that Obama's portion is kind of take over the social media in Twitter. But you see that there are other hashtags that, depending on what day and what's going on that day, you see that different hashtags are coming. I just look at the top 6 hashtags. And it's interesting because I think it's kind of useful because when you look at the hashtags, you can get a sense of what people are discussing as a kind of high-level topics. Yeah. Therefore, those are the basic kind of statistics, kind of analysis. And then the next question that was in my mind, okay, during the hackathon was that, okay, how can we try to somehow formulate prediction problem, okay? And obvious answer is that, okay, what if we look at the sentiment of tweets and see how many positive tweets are posted for Obama versus Romney? Therefore, okay, the analysis that I wanted to do was, of course, sentiment analysis. But the question is that, okay, how can I do it? And the obvious choice, the first choice, is using kind of Bayesian framework. And the first things that came to my mind was using naive-Bayes classifier. Okay? And why I decided to use that? The main reason is that because of this, it's simple to implement. Because all of the analysis that I'm explaining here is basically I implemented the Java library. Therefore, all of them are implemented from scratch by me. Therefore, but naive-Bayes is very simple in terms of implementation. But you can see, I mean, if you implement it and you use it, you will see that in practice performs reasonably well. Those were the main justification. Okay. Therefore, the question is that if I have a tweet.
So, how are you generating tables?
How are
you generating the tables? Like what? Like you have to at some point go in and be like, this is a positive tweet.
Yeah, I'm getting there.
Okay.
Therefore, you can think about the tweet as a bag of words. Okay, bag of words. Therefore, the ordering is not important. And I show that first line, the words. I mean, the tweet is it has n words that we want to value n. And of course, we want to use Bayesian framework. Therefore, the posterior probability here is that what is the probability that this tweet has a positive tone given the tweet. And of course, I mean, it's clear that the way that you factorize that, you say, okay, this is pure probability multiplied by likelihood. That's the Bayesian statistic. But the nice part of, at the same time, the weak point of naive-Bayes classifier is the independence assumption. You make an independence assumption, and now you can practically compute the likelihood, okay? Therefore, basically, you say that the likelihood, given the label, what is the chance that I see this bag of words that you want to value n? The assumption that you make is that given the label, the features are independent, therefore you can factorize that joint probability to the product of each conditional probability of probability of seeing each word given that label. And that label, as I said, can be either neutral, negative, or positive. And of course, this is the beautiful part that, as I said, that naive-Bayes is very simple to implement. And basically, that conditional probability, your likelihood, can be boiled down to just a count. Therefore, you just count the number of times you have seen positive tweet in the denominator. You add the vocabulary size. This is a Laplacian kind of. You use Laplacian in order to get, in order to handle the zero frequency issue. But in the numerator, basically, you count how many times that word appeared in the negative or positive or neutral tweet. As I mentioned, this is the big assumption in naive-Bayes, which is at the same time makes it the weak point of assumption. Why? Because in practice, you cannot make that assumption. You cannot assume that even the label, the words are independent. No, the words are not independent, but it's a practical assumption that we can make and we can move on. Going back to your question that, okay, how did we do the classification? As you guys know, naive-Bayes classifier is supervised learning algorithm. Therefore, me and my friend, I randomly sampled 1,000 tweets, and we sat down and then we went through that. Each person went through that once, and then I went through that again, and we labeled each tweet being positive or negative. Okay. And I can recall that when I did it for hackathon, I used there are some training data out there for IMDb. There are some training data for IMDb that they come with the sentiment, but the important thing is that when you want to use IMDb reviews as a training data, that's not going to work well. That's the thing that I found, because the context is very different, the language is very different. In Twitter, people use lots of slang that no expert uses in IMDb review. Therefore, in the beginning, I was using IMDb review as a training data, but at some point I realized that, oh, this is going to hurt the classifier. Therefore, we just did that manually by ourselves. So did that answer your question?
Yeah. How much beer did you drink?
Sorry?
How much beer did you have to drink?
How much what?
How much beer did you have to drink?
Beer? I had to drink. Yeah. Yeah, I like drinking beer. I like getting hammered, actually. But yeah, I don't remember that one why I was writing, because, yeah. But going back to the slide, when you want to, how do we run this naive base? I think it's very straightforward. I don't want to waste everybody's time, but let's go through it. Therefore, you have the tweet, you segment the tweet into words. Of course, you remove stop words, assuming that stop words are noise. You want to remove noise, okay? There doesn't mean anything. And is, where those kind of words should be removed, because they are not going to help your classifier in order to make the right decision. One problem when you run the naive-based classifier in this scale, you will notice that because the words are very, very sparse, the chance that some words happen, whether in positive, negative, or neutral twist, is very, very low probability you will find. Therefore, if you use the straight probability, when I was talking about the likelihood, if you just compute the straight probability, you will get into the problem of low precision. To handle that problem, of course, you should use logarithm. Therefore, you kind of handle that problem. But maybe the most interesting part is that negation. How do you do with negation? To handle negation, we again modify the basic naive-based classifier. Therefore, we handle negation separately, in the sense that if there was a negative word, we put a not in front of all the consequent word up to a stop word, and up to punctuation. And this is it's very popular technique that everybody does. Okay, this is the fun part. Positive tweets. I ran the sentiment analysis for this 50-something number of days, and then I computed the number of positive tweets for both candidates, Obama and Romney. For each day, I randomly sampled 10,000 tweets, and I just analyzed those tweets that they mentioned one candidate name. Because when both candidate names in the Twitter, then in the tweet, the problem becomes much more complicated. Therefore, I didn't want to get into that complexity. Therefore, I just simplified my problem in the first place. Because I want to see what is the public opinion in general. Okay. I mentioned that there was 10,000 random sample, and I just look at the tweets that they mentioned, Obama or Romney. The blue one is Obama. When you look at the trend, what do you see? Okay. In the beginning, Obama, first of all, is always leading Romney, which is kind of trivial, because the number of tweets for Obama was leading Romney. If you think about probability, okay, when you have that kind of things, that naturally leads to having more positive tweets for Obama. But when we are getting, and this is the crash, but when we are getting closer to election, which is November 6th, you see that you start seeing a gap between these two. And I think that's the key point, that's the key observation that you can make, that when you are getting close to election, people's opinion becomes much more clear. And probably that's actually after this third debate, which is October 22nd. And, another interesting thing that I want to point out here is the number of positive tweets. the number of positive tweets are in the order of hundreds. Okay? Now, if you look at the next slide, which is the negative tweets, this is interesting. And I think if anybody followed election last year, you could hear that, oh, campaigns realize that the negative advertising is the key. Therefore, don't talk about your candidate, just destroy your opponent candidate. So,
curious, when you're looking at the negative tweets, when you're doing your manual bit for this, did you detect any obvious bots?
Obvious bot, good question.
Yeah.
I will get to that. Yeah, I will get to that one. That was the reason I was saying that geolocation is kind of gold data. How? Because bot cannot use mobile.
Yeah.
Therefore, they're using web as a source of tweeting. Yeah, but that's a very good question. I mean, I didn't look at that explicitly. Yeah, because that was not the main issue. But as I said, for example, Romney bought 20 million fake followers. And I'm pretty sure that he bought also other things. And okay, but you see the number of negative tweets are in the order of thousands, okay? And again, you see the same pattern. Therefore, there is a correlation between this graph and the previous graph. You see the same pattern after October 20th, after October 31st, you see that all of a sudden you see a gap between these two. Yeah, going back to your question, yeah, we want to make sure that we don't analyze the tweets that they are generated by bot. That was the reason that in the beginning I mentioned that those tweets that they are coming with geo tags are very valuable because we know for sure that those tweets are coming from mobile phones. Okay, therefore are real people. Therefore, the next question was that, okay, if we run the sentiment analysis, but this time instead of running it on the whole bulk of tweets, which majority of them don't have geolocation, just filter the ones that they don't have geolocation, just focus on the ones that they come with geolocation, which were like 140K. It's not low number. It's not very large number compared to 40 millions, but it's not low number statistically when you think about it. Therefore, what I did was that I used KD3, and then I pushed all of the states and cities, US cities and state geolocation into KD3, and after that, I just, for each of tweets that they had geolocation, I just asked the first nearest neighbor, closest nearest neighbor question in order to find, for each tweet, in order to find to what state that tweet belonged to. Okay? It's coming from what state or what city. And then I categorize those tweets based on the state. Therefore, you see on the first column here, state. The second column, therefore, for example, W, I think it's Washington, what is that? Yeah. There are lots of states there, 50 something. I know California. CA, that's the one. I know this one too, Texas. The second column was that, okay, the second column was the proportion of positive tweets for Obama to Romney. Therefore, it's a fraction when in the numerator you have the number of positive tweets for Obama, and in the denominator you have the number of positive tweets for Romney. The same thing for the third column. The only difference is that it's negative tweets. Therefore, if the second column is higher, that means that people tweeted more positive tweets for Obama compared to Romney. But if the third column is higher, that means that people tweeted more negative tweets for Obama compared to Romney. First one is the number of geolocation tweets that we got for that state during that period, 50 something number of days. And the last column is the output of prediction, because we know that that's the final output of election result for that state. Therefore, if the word Obama is there, that means that Obama won that state, and the last number is the electoral votes associated with that state. Okay? Because basically what they do, if your popular vote passes your opponent, what happens is that you get all electoral votes for that state, and at the end they just count the electoral votes, and if you pass the majority, then I think you won the election. And what happened that Obama won 302 electoral votes, and Romney was like 260. Right? I just did this analysis last week, and then I was looking and I said, okay, this is the output of this is the output, this is the final output that we know for sure, that's the, and these are some kind of very first try features that I just came up in 1 minute. I didn't spend any time to think about them. I just said, okay, let's look at positive ratio and negative ratio. But there are some interesting observations that you can make here. I'm not claiming that I predicted the election result, but I'm saying that you can make some kind of observation here that's kind of interesting. For example, if you look at the DC state, you'll see that the ratio of positive is 193. There is a gap. There is a gap between the positive ratio compared to negative ratio, and you see that Obama won that state. If you look at Hawaii, HI, the population over there is not high, but you see that the positive tweets are way higher. Gap is huge, and Obama won. Wyoming, when you look at Wyoming, you see that the number of positive tweets is 1, it's kind of balanced, but the negative tweets for Obama is huge compared to 1, and Romney won. But the thing about we should, just be careful is that this number, therefore that gives you some confidence that when you want to infer that kind of conclusion, how much you can be confident. And Texas, which is the south of US, and you know that it's a very conservative city, conservative state, except big cities over there, you see that negative tweets is higher than Romney. California, the number of positive tweets is 1.69, number of negative tweets is 1.39, and Obama. Next slide. And Arizona, I didn't know Arizona is kind of conservative state. And the ratio of negative tweets is 3.43, positive 1.14. It's very balanced. Romney. Maine is a very small state in northeast. The population is, I think, under 1 million or I don't know, something like that. And again, you see there is a big, huge lead for Obama compared to Romney, and Obama, of course, wins. And that's it. Yeah, those was the basic analysis that I wanted to share with you guys. It's kind of ongoing research. Therefore, those are the first early results that I got from the sentiment analysis. But the previous company that I was working was Secret Solution, and I was doing machine learning over there. And one of the techniques that I used there was we use latent Dirichlet allocation. Okay, I read the original paper, which was from Blay, very famous guy who is right now in Princeton, is doing machine learning. And of course, Andrew N, which is leading machine learning kind of things in Stanford, and I don't know the third guy. Anyway, they wrote a paper, I think back 2000 something, to latent Dirichlet allocation. And what is the algorithm about? In general, I'm very fan of unsupervised techniques because they are very, very powerful compared to supervised learning techniques. And when you look at their math, you will see that you can see that where the power comes from. But to just go very briefly through the LDA. I don't want to spend, because the math is very detailed, I don't want to spend time going there. I just want to give you some feeling about how algorithm performs in high level, and then you guys, if you think that this is a fit for your app, then you can use it for your own purpose. Basically, one of the obvious usage for LDA is, as I mentioned over there, is topic modeling. If you think about documents, let's say you have collected this many papers, you have tons, like, I don't know, suppose that you wrote a crawler and you collected 100,000 Wikipedia page. How do you want to organize them? It's very hard to organize. And what I mean with organization means that how can you organize them in the sense that putting for example, the Wikipedia articles that they talk about, let's say, genetic science together, the ones that they talk about, let's say, computer science together, and etc. This algorithm tries to do that. And how does that do it? Is that basically the algorithm is a highly called Bayesian framework, and what the assumption that it makes this assumption that the author who wrote this book, he has a list of topics in his mind. Therefore, basically, you model everything using probability. And the way that he generated this document supposedly was like this, that there were a list of documents, sorry, the list of topics that I had in my mind, and basically each topic is a distribution over vocabulary words. You have a finite size of vocabulary, and you can model each topic as a distribution over words. For example, here the first topic, it seems is like genetics, and you see that, for example, gene appears under that topic with probability of 4%, DNA 2%, and blah, blah. The second one probably is about life and organism or something like that. And you see again the words and their probability. Therefore, you have a distribution for each topic. You can represent each topic as a distribution over words. Then what happens to me as the author when I want to generate, this is the generative model. Therefore, when I wanted to generate this document, I had, let's say, 3 topics in my mind, and there was a distribution, that's the distribution. There was a distribution over topics. Here there are red, yellow, and kind of blue. Therefore, my mind, in the first place, picking one of these topics, I'm tossing a coin, and then based on the result of the coin, and I pick a topic. Let's say that I pick red this time. I go to red topic here, and then again I toss another coin, and then based on that I generate the word, and then I drop the word. And then I keep generating this document using that kind of generative model. Therefore, that's the underlying assumption. Having said that, what happens that this LDA tries to, given the observation variables that here are basically words that they appear in the document, they try to compute the probability distribution of topics given the words. Therefore, hidden variables or latent variables here are the topics. Therefore, those are the distribution that you are interested in. You want to find the distribution of topics, okay? And basically the same idea, Bayesian framework, posterior, you factorize posterior as superior product likelihood, and then they use, for example, sophisticated techniques in order to compute likelihood, which is the hardest part. Therefore, and this is basically the representation of that graphical model that I said, and that's basically the underlying model for LDA. Okay, therefore, this is not done yet. I mean, it's kind of ongoing. Therefore, I implemented LDA because I already implemented in that company, in secret solution, and then I implemented again myself in summer, and I wanted to see when I run LDA on top of tweets what I would get. But the main reason that I did was that, okay, if for one day I have 10 million tweets, what company is going to read 10 million tweets and organize them? It's not manual work. It should be machine work. Therefore, that's the reason that I wanted to run this algorithm to do that for me automatically. Therefore, I say that, okay, let's run LDA on different days, and I chose, you have to specify, when you run this algorithm, you have to specify, the only parameter that you have to specify and give it to the algorithm is the number of topics. And choosing number of topics, there are techniques for doing that, but I picked a number, I just said, okay, on one day, how many topics people can talk? Of course, if the number of documents is n, the number of topics is going to be in the order of log n. It's not going to be in the order of n. Okay? Therefore, mathematically log n. Therefore, if you have for one day, you have 1 million tweets, you are going to see like log of 1 million as the number of topics that people discuss. Therefore, let's pick 5. And let's look at the first presidential debate, October 3rd. And see what topics we are getting back. T1, T2 to T5 are basically the columns. And as I said, if you remember, I said that a topic definition is that it is basically a distribution over your vocabulary words. Therefore, what I did, I basically sorted my words under each topic based on the chance that they appear under that topic. Therefore, there is no any topic. Therefore, you can look at the words and try to somehow, I don't know, infer that, oh, what this topic is about, okay? But basically, a topic mathematical definition is that this is a probability distribution. Okay, the first topic, you see that there is debate. Okay, of course, that day was about, I mean, the first thing is that the very top words, the very words that they appear on the top, it's very high likelihood. Under each topic is Obama-Romney, which is obvious, and you see debate, and the very last column is interesting. If you, I don't know if anybody watched that debate was about, I think it was about US economy. Therefore, you see that there are many people that started talking about the class, middle class, of course, tax cut, taxes, and blah, blah, blah. But the interesting part was this. I just ran this several days ago. And then I saw, oh, Michelle, anniversary. What does that mean? I didn't have any idea that, oh, October 3rd was anniversary of Michelle Obama with Barack Obama. Okay, that was their anniversary. Therefore, the algorithm found that kind of topic that people were discussing in Twitter, and it highlighted that for me. Therefore, now, me as an analyst, when I look at the data, I can find those kind of those kind of conversations that they are happening underneath. Therefore, that was an interesting observation.
Two quick questions for you about the topics. First, are they stable? If you rerun the algorithm again, will it pick the same topics?
Good question.
Because there's non-determinism.
It's not deterministic, but of course those words that, as I said, no, the topics, the definition is the distribution over words.
Yeah.
Therefore, those words that are strongly correlated with that topic, no, there is no any T1, T2. That's meaningless. Therefore, we don't talk about, that was the thing I was saying, that you just spit out the words, and when you look at the words, you, as a human, look at that and say, oh, this is the topic problem.
Yeah. Okay. The second question was, I noticed there's GT and AMP in there, and I assume that's HTML characterized as being...
GT?
Yeah. After tonight...
No, GT is kind of abbreviation in Twitter. I forgot what was it.
Okay. It's not HTML.
No, it's not HTML. It's I don't remember what was the meaning, but I look at that several months ago.
Did you stem as well?
Sorry?
I know you use software. Did you stem as well?
This is a good question. Because no, okay, if you go online, you will see that Belay has a presentation presenting his algorithm, and one person asked the same question, do you stem before running LDA or not? And his suggestion is that just make sure, stemming is going to help in general, but just make sure that you don't pick a very aggressive stemmer. If you use an aggressive stemmer, it might hurt. That was his suggestion, but I didn't use any stemming app beforehand. Therefore, that's the basic, the raw words. I just removed this stop word. Yeah, I just removed stop words. Second presidential debate. When you look at that, probably the third column. Again, you see the second presidential debate was also about internal kind of domestic kind of plans and domestic issues, and you see that they talk about plan, debate, trillions, cut, taxes. Again, that was one of the topics. In the fourth topic, I saw the word woman. I recall that there was a debate, I think it was the second debate, that Romney made a statement about women. I don't remember exactly what he made, but I was guessing that I didn't have a chance to go back to the debate and watch it to see what happened. But what happened that when he made some statement in his debate about women, I think there were lots of anger on women's side, therefore they started being angry about it. But I don't know, maybe that's the reason that the woman appears. Yeah, and of course you see that here, Libya, again, Benghazi attack. Third debate. Okay, it was about foreign policy. My country is here. Therefore, Iran was mentioned. I'm from Iran, okay? Iran was mentioned. one of the, I think, big challenges that they mentioned about it. And probably Romney was kind of blaming Obama that, you are not, aggressive. No, in your foreign policy, you are not aggressive. And I think that was one of the challenge. And you see debate, foreign policy, blah, blah. Bin Laden mentioned, I remember that one of the things that Obama campaign was kind of trying to somehow use it as a positive thing for Obama was the fact that they killed Bin Laden last year as a successful kind of foreign policy. And okay, the last column again, you see.
Bayonets and horses.
Sorry?
Bayonets and horses jumped out at me, and I was wondering if you looked at that at all.
Yeah. Yeah, just to wrap up, therefore, I don't want to claim that, the last one. Just to wrap up, no, we can go to conclusion. Just to see that what was my main observation here. Okay, predicting the future using Twitter data is challenging. Many people don't like this kind of statement. They are saying that it's not possible. But there are lots of effort people are putting in order to predict the stock market using Twitter, predict flu outbreak using Twitter, and election. One of the challenge, one of the critics is that Twitter data is biased by young people, young generation, and tech people, and those people are in the favor of Obama. Therefore, probably that's the reason that you see lots of positive and positives for Obama compared to Romney, which is kind of true. But we saw that Obama was leading Twitter for US 2012 election as 2008. Therefore, again, it was a successful campaign for Obama. And one interesting observation, which is very interesting from a marketing point of view, is that negative advertising seems, because I met Obama's advisor several months ago, and he was saying that they didn't use very sophisticated machine learning technique in order to, for example, run the campaign. They use basic statistics, and the other thing that they did, basically they took lots of theories and lots of lessons from marketing space, and they were trying to use those ones in order to change those people's mind that they haven't made their decision yet. Therefore, we found that joke tweets are very kind of what should I say, useful data for analysis. And again, LDA is a powerful unsupervised technique for natural language processing and other things. And very last thing, as I mentioned, we are at Trulio, we are hiring data scientists, machine learning, people who have experience with machine learning and data mining. And basically what we do is that we are building machine learning in order to verify people's identity. Therefore, if you are using your Facebook profile, for example, we try to say that if you are an authenticate user or no, you are a bot or fake. Okay, that's kind of thing. Therefore, if you are interested, you can go to that Trulio website and then apply for. And that's it. Any questions?
So I just had a question. When you were choosing your 1K data set for training with Romney and Obama, if, for example, Obama was really positive and Romney was really negative, you would be training in favor of what you were seeing. So did you choose like 50% positive, 50% negative for each of the, when you were collecting data?
When I wanted to build the training data, I just randomly sampled from all of my tweets. Therefore, that was the way that I tried.
So when you're doing this sentiment analysis, I know there's lots of packages out there that do sentiment analysis, and it's less hassle than you doing 1,000 ratings yourself. Did you consider doing that, or was there? Did you just think that there was going to be more added value if you went ahead and rated the tweets yourself?
Okay, the question is that why I didn't use other implementation for sentiment analysis? Okay, I see.
Or compare with that to see how it would affect your results. Would you get similar results from using a standard package as with your own training sample?
Yeah. No, I didn't do that. I didn't do that. But one interesting thing that I realized 1 month ago is that there is a research in Stanford. Right now the breakthrough kind of techniques in machine learning is deep learning. I don't know if you guys heard deep learning technique. And I realized that 1 month ago, people in Stanford, they use deep learning technique, which is the leading kind of algorithm in machine learning to do sentiment analysis. I'd like to use that at some point. Nobody never used it.
I was just wondering if you use the ratio of positive and negative tweets as a classifier, what kind of accuracy do you get on your election prediction there? Or
there were cases that that prediction didn't do it better. But I didn't look at that because this is some result that I got a few days ago. No, I didn't look at that. Therefore, I'm not claiming that's a predictor. I was just trying to make see if there is a connection between those and the result. Yeah.
Actually, just kind of comments. So there's some people who study history and suggest that there's 12 different cultures within the U.S. Did you try looking for clusters among the way people kind of voted? Were there
different cultures?
Well, they say American, but there's supposedly 12 different cultures in the States that resulted from different migrations over from Europe and...
No, I didn't go that much deep.
Okay.
No, I didn't go that much deep.
Let's one back.
So how do you eliminate false positives from this data? For instance, on October 3rd, you said that Michelle and Obama had their anniversary. So Obama might have got more positive feeds on that day, but that's not related to the election. So that entire topic that got modeled on that particular day is irrelevant to the actual election results or popularity. So how do you eliminate false positives in
For what? For what?
For LDA. So that's not.
What do you mean false positive for LDA?
So if on that particular day Obama's popularity was not directly linked to the election outcome, right?
Okay.
So but he's popular that day. He's positively popular, I would say.
Because LDA doesn't talk about the positive or negative.
So how do you eliminate such instances? Or can you eliminate such instances?
Yeah, we can talk this offline,
Okay,
because it's kind of... Yeah.
We're going to have brownstones afterwards if you want to talk to them. Okay. So are you ready?
Yeah, thank you.